Unit 6.6, Day 1. Our learning target today is to solve logarithmic equations. A logarithmic equation is an equation with a logarithmic expression that contains a variable. Solve logarithms by using the properties of logarithms. If log with a base b of x is equal to log with a base b of y, then we can assume that x is equal to y. So if x is greater than 0 and y is greater than 0, they should be equal. But why does this work? So we have three different methods to solve logarithmic equations. So in example 1, we have log with a base of 3 of x minus 5 is equal to 2. Method number 1 we're going to discuss is the inverse method. The inverse method states that we can take both of these and raise each side with a base of 3. So because this base right here is 3, we can raise this side, we can put 3 as both of our bases on either side. When we have 3 raised to a log of 3, that equals 1 whole, so we're given x minus 5 on the left, and I know that 3 squared is equal to 9. I can then add my 5, and I know x is equal to 14. Method number 2 is called log equals log. So if we have log with a base 3 of x minus 5 is equal to 2, I can rewrite log with a base 3 of x minus 5 on the left-hand side. And if I add log with a base 3 of 3, I know that equals 1 whole. When I raise that to the second power, I'm still left with my 2, so I didn't change the right-hand side of my problem. Now, I have x minus 5 is equal to 3 squared. X minus 5 equals 9. Add my 5 because it's my inverse operation, and I get x is equal to 14. Looking at method 3, if we write exponentially, I ask myself 3 to the second power is equal to x minus 5. 3 squared is 9. To move my negative 5, I add it, and I get 14 is equal to x. So all three of these methods you can use to solve logarithmic equations, and you will end up with the exact same answer. Example number 2, we have log 45x minus log 3 equals 1. So the first thing I want to notice is I need to use my quotient property because I have a subtraction sign. So I want to write things as a single log. Log 45x over 3 equals 1. 45x divided by 3 is 15x. And I notice that my common log is a 10 that is invisible. I then, if I used method 3, I could rewrite this exponentially by saying 10 to the first power is equal to 15x, divide by my 15, and I get x is equal to 2/3. You could have solved this using method 1, method 2, or 3. I just chose 3 for that example. In example 3, I have log with a base 4 of x squared is equal to 3. Again, if I use method 3, I say 4 to the third power is equal to x squared. 4 to the third is 64. Take the square root of both sides, and I get x is equal to plus or minus 8. Example number 4, I have log with a base of 12 plus of x plus log with a base of 12 of x plus 1 equals 1. So in this example, the first thing that I want to do is write it as a single log. So we write log with a base of 12 of x times x plus 1 is equal to 1. After it is written as a single log, if I use method 1, I notate what my base is, and I'm going to say 12 to the log with a base 12, x times x plus 1, is equal to 12 to the first power. I then 12 raised to the log of 12 equals 1. So I have x times x plus 1 equals 12 to the first power is 12. X squared plus x equals 12. Inverse of addition is subtraction. X squared plus x minus 12 equals 0. Factor. I know 4 times 3 equals 12. I need a positive x, so I'm going to have my 3 negative, my 4 positive. If I set each of these equal to 0, x minus 3 equals 0, I get x is equal to positive 3. X plus 4 equals 0, I get x is equal to negative 4. And then we need to check and make sure. You can never have a negative log. So if you look up here at log base 12 of x, if I were to plug this negative 4 in, that would give us a negative log, and that would not make sense. So our only solution to this is x is equal to 3. In example 5, we have 2 times log with a base 5 of x minus log with the base 5 of 6 is equal to log with the base 5 of 3. So the first thing I notice is I want to use my power property and rewrite this as log with a base 5 of x squared minus log with a base 5 of 6 equals log with the base 5 of 3. I then notice my subtraction, so I want to write this as a single log. Log with the base 5 of x squared over 6 is equal to log with a base 5 of 3. I now recognize that my logs match one another, so I can write x squared over 6 is equal to 3, and then solve using inverse properties. X squared is equal to 18. Square root of 18 gives us x is equal to plus or minus 3 square root of 2. Again, looking up here, I notice that if I were to plug negative 3 square root of 2 in for x, my x would be less than 0. So it would give me a false statement, so we want to only use 3 square roots of 2.